For this first question, we need to know what the equation of a circle is because asking us it's asking us to write the equation of a circle. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. So this h and k right here, that's our center, and it comes from the coordinate that they gave us. The h is the x coordinate, and the k is the y coordinate, and right here on the end, that's just our radius squared. So we're going to plug in that center of -2, -1. And in our final answer, it that center is just once it's plugged in, it changes sign from what you see. So in the equation, the two that was negative is positive, and the one that was positive, we see y minus 1. And on the end here, we just want to square the radius. The radius was 3, so 3 squared is 9. So that's our equation, and we will just use the center from up here, the -2, 1, to plot the center of the equation in the graph. So -2, 1 lies right here. Once we have the center plotted, we will count out 3 units in any direction at all, to put one of our endpoints, and that will be our circle. For question number 2, just again remember what that equation of a circle is. So you can see that our y does not have a y minus k right there. So the y coordinate, it just has a y squared. The y coordinate ends up being 0 because there's nothing there. Y doesn't have anything subtracted from it. It's 0 of anything that's subtracted. You see that for the x, I wrote down a -2.5 because, again, what you see in the equation is the opposite sign of what the actual coordinate is. So it was positive in the equation, it's negative in the coordinate. For the radius squared right here on the end was 27.04. So to get the radius, I need to take the square root of the radius squared. So the square root of 27.04 is 5.2. So right here on question 3, we have several different parts. The first part we can see right here, f of -4. And when you're asked that question, it's saying when your x value is -4. -4 right here is an x. When your x value is -4, what is your y value? So all I want to do is look at the x value of -4 right here and see what that y value is, and it just crosses the x-axis at -4, so that y value ends up being 0. It also asks us what f of part 2 is, what f of 1 is. So I would go to the x-axis, go to the x value of 1 and see what y value I have for the x value of 1, and the y value for the x value of 1 would be right here at -1. This next part says to find all the values for which f of x is equal to -1. What that means is right here, f of x, that's y. F of x equals and y equals are one and the same. They can be used interchangeably. So find all values, and right here it was supposed to say x values. Find all x values for which f of x, for which y equals -1. So you'll want to come down here to look at the y value of -1 right here, and you want to see where you have graph at the y value of -1. Well, you have it right here, and here, and here. So what are those x values? At -3, +1, and +3. That's where we have a y value of -1 and the x values of -3, +1, and +3. The way you want to write that in no particular order, you would just, it has the box, and you're going to type in -3, +1, and +3. That doesn't have to be in any particular order. Part 4 is very much the same kind of question. We're looking at the y value of -4. So right here, at the y value of -4, where do we have graph at the y value of -4? I don't have graph anywhere until I get right here. That's an x value of 0. And then I have graph at the y value of -4 right here, and that's at the x value of -4. So again, you're looking at the y value of a -4, and where do you have graph at that y value? Well, I have graph right here and right here. So what are those? What are those x values? They are 0 and they are +4. Part 5 asks us what the x-intercepts are. And so an x-intercept is where you cross the x-axis. It wants the answer as an ordered pair. So we cross the x-axis or touch the x-axis right here at the point, that's the point -4, 0. So let me write that one down. And let's see if there's another x-intercept. There is another x-intercept. We touch the x-axis again at the point 2, 0. And I just wrote the and symbol there, but you're actually going to type it in using a comma in between. That next part asks what the y-intercepts are. So y-intercepts would be where you cross the y-axis. So we are looking right here at the y-axis, and where we cross that at, that's the point 0, -4. And that's the only place that this graph crosses the y-axis. So 0, -4 is our only answer there. Part 7 and 8 asks about the domain and range. So let's just remember that our domain is our x values, where we have x values at. Okay, so we're going to work from left to right. So automatically, starting off at my furthest left, I have x values. I have this arrow upward and to the left, which is telling me that we're starting off with our domain at -infinity. And so now going back and looking at it, um, going left to right, -infinity over here, and I keep going, I still have x values, I'm having x values still, got x values still. I'm going left to right. So I got graph, 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 and I get here to 4, and I stop. And if I didn't have anything here, up here that I jumped to, and I just stopped, I would put a bracket and a 4 right there to end my x values. However, we worked left to right, we got to 4, it stopped, and it picked back up. It picked back up right up here. So this will actually be from -infinity to +infinity. We did have a stop, but again, it picked back up right at that same x value and went to the right with an arrow. So from -infinity to +infinity is our domain. In our range, we want to look at the y values. We're going to work from negative to positive. When we worked from negative to positive on our x-axis, it was left to right, but working from negative to positive on our y-axis, it's from bottom to top. So right here at the very bottom, I was trying to get my selector real quick, sorry. Right here at the very bottom, I don't have any graph yet. And there's not an arrow that's pointing down. So I know it's not negative infinity. Well, I don't have a graph, don't have a graph, don't have a graph, and I'm working my way up. And all of a sudden, I start having graph right here at the y value of -4. And since I have this closed circle right here, I'm going to put a bracket. So my graph, my y values start at -4. And let's see how long they last. So going back from -4, graph, 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 still have graph. Let me zoom out a little bit so we can still look. Oh, oops. Graph, 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 working my way up, working my way up, working my way up. And I have this arrow upward and to the left. It doesn't matter when you're working with range that it's to the left. It just matters that it's going upward for infinity. And so this graph ends at positive infinity. We have y values to positive infinity. Now, I do realize that we have graph right here at +4, but really, whenever I say we have graph from -4 to positive infinity, it's including that +4 value that's right there. So finally, we're on another question. Use the point slope formula to write an equation of a line that passes through the point 5, 4, has a slope of 0. So right here at the top, we have the point slope formula. And I went ahead and highlighted areas where we're going to plug things in at. I already have the slope of 0 and the point given to me. So the only thing I need to do is plug in. So I will say y minus the y value of 4 equals the slope of 0 times x minus the x value of 5. And now I can just distribute that 0 to get 0 times x is 0, 0 times -5 is 0. If I am solving for, if I'm putting it in y equals form, I do need that y by itself. So I will move that -4 to the other side. And this is the answer right here. It is slope-intercept form, the form y equals mx plus b. The reason that I don't have an x in this final answer is because that slope was 0, and it just made that x go away whenever we multiply it out. So y equals 4 is our answer to the equation for this problem. Now on number 5, it wants us to determine if the lines are parallel, perpendicular, or neither. Well, if lines are parallel, that means they have the same slope. If lines are perpendicular, they have to accomplish two things. They have to be different signs, and in the notes or in a textbook, you would see that written as opposite. And they also have to be reciprocals, or they have to be flipped. And again, in the textbook, you would see that written as reciprocals. Okay, so, and then neither is if, well, they're neither parallel nor perpendicular. Well, on this one, it's these two lines are sort of I guess a special case. Uh, I guess another thing I should mention on parallel, perpendicular, and neither, parallel lines look like a highway, okay? And then perpendicular lines look like a four-way stop. anyway, with these, you don't necessarily see the slope. This line right here, y equals negative 5, y equals negative 10, is really the line y equals 2, which if you graphed that out, that would be a horizontal line through the y value of 2. And over here on the bottom, we got x equals negative 2. Well, that is a vertical line through the x value of negative 2. So what these two lines are perpendicular. If they intersected, they would, if they were drawn on one graph, they would intersect and form perfect 90-degree angles. And so we actually answered this question without knowing the slopes. Now the slope of y equals 2 is actually 0, and the slope of x equals negative 2 is undefined. And that's because the slope of a horizontal line is 0, the slope of a vertical line is undefined. Anyway, graph the equation and identify the x and y intercepts. So it helps to know what an x and y intercept is, and we actually covered that in question number 3. It's where you cross the x and the y axis, okay? So where you intersect the x axis is an x intercept, where you intersect a y axis is a y intercept. Anyway, an easy way to do this, if it's an x-intercept, it's going to be some number, some x value for your x value, some number value x, and your y value will always be 0. And if it's a y-intercept, you're going to have a 0 for your x and some number for your y value. So what we can do to find this x and y intercept is just draw an x y chart, and if we plug in 0 for y, that will produce an x intercept, and if we plug in 0 for x, it will produce a y intercept. So let's just try to do that really quickly. 4y equals 3x plus 12. 3x plus 12, we're going to plug 0 in for y, so 4 times 0 equals 3x plus 12. 0 equals 3x plus 12. Negative 3x equals 12. I just moved that 3 over, and so divide both sides by negative 3 and you get negative 4. That's an x-intercept. And then our y-intercept would be, we need to plug in 0 for x, so 4y equals 3x plus 12. 4y equals 3 times 0 plus 12. 4y equals 12, y equals 3. So that's the point 0, 3, and that's a y-intercept. So on the next page, I'm just going to plot those 2 points. We had 0, 3 as our y-intercept, and negative 4, 0 as our x-intercept. Just plot those 2 points and use your line tool to make that line happen. So question number 7 wants us to write the equation of a line, and it says use that point slope formula of y minus y sub 1 equals the slope times x minus x sub 1, and you would just plug in that x and y value in the respective spot into that formula. But really, it didn't give us a slope, and in fact, what it told us about the slope is that it's undefined. Well, I can't plug in an undefined slope. If it was a slope of 0, yeah, I can plug in the number 0, but I can't plug in a number for undefined. So in this case, it helps to know what an undefined slope looks like. That's an undefined slope, just a vertical line, and that vertical line is going to cross through the x-axis, because I mean, if you have an xy axis, that vertical line is going to cross the x-axis, not the y-axis. Anyway, the equation of this line is just x equals that x value of negative 2/3, and it's because the slope of the line is undefined. Now the question gets more interesting on number 8, because we're writing the equation of a line again, now it does say to use slope-intercept form. That would be y equals mx plus b. Plug in your x and y, your x and your y, and then your m to solve for b. Another thing that you could use is the point slope formula, which is really the way I do it most of the time. Um, and it's the way that I would do it. But since the directions say to use slope intercept form to get the equation of a line, I'll go ahead and show you that way to do it. Okay, so what we have to have is we're going to need to plug in our y value, and I can just choose from any one of these points. Let's just say I'll use the first point. So -5 would equal the slope. Well, I don't have anything to plug in right there yet. And then I do have an x value of -10 from this point right here. And I'm going to solve for b. So I don't know what the slope is to plug that in just yet, but I can find it because I have these 2 points right here. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I will just plug in that y sub 2 value of 1, subtract -5 from that, and divide that by -4. That's x sub 2, minus that x sub 1 value of -10. That comes out y minus a -5, 1 minus a -5 is a +6, and -4 minus a -10 is a +6 as well. So the slope is 1. I'm going to come right here and say now -5 equals, let me see if I can change that -5. There we go. -5 equals the slope of 1 times -10 plus b. And I'm going to end up finding out what b equals. I can add 10 to both sides to get 5 equals b. So now that I know that b is equal to 5 and m is equal to 1, the slope is equal to 1, I can go to my y equals mx plus b, and instead of solving for something, I'm just going to write what the equation is this time. I can say that y equals 1x plus 5. So we're just going to write that as x plus 5. You could have done this same problem using the point slope formula. And I'll just show you that really quickly. Y minus y sub 1 equals the slope times x minus x sub 1. Of course, you would have still had to find that slope first. But from there, you can just use that first coordinate of -10, -5, and say y minus -5 equals the slope of 1 times x minus -10. Clean that up a bit. Y plus 5 equals, so minus a negative is positive, and I'll distribute the 1, so that's going to be x plus 10, and then you can subtract 5 from both sides to get y by itself. It still gives you the same answer. We already answered this question on the last page, but so y equals x plus 5, but just know that when it's asking you for function notation, it just wants you to, instead of writing y equals, it wants you to put f of x equals. On question number 9, it wants us to determine if these slopes are, or if these equations are parallel, perpendicular, or neither. So parallel lines, just remember, have same slope. Perpendicular are opposite reciprocal, which means change your sign and flip, and then neither would be neither parallel nor perpendicular. Well, the slope here on the first line is 2/5, and the slope on the second line is a different sign, so it's -5/2. So that's what reciprocal means. It's the flipped version of it. So these lines are perpendicular because they were both opposite and reciprocal. Now, on question number 10, does this relation uh, define as a function? Well, just know in a coordinate, in a relation, its set of coordinates, the x values cannot repeat. So really, you don't see this as a set of coordinates, but it is -3, 6, -10, 5, and -10, 10. So we do have x values that repeat. That x value of -10 has two different y values, and that is not a function when your x values repeat and have different y values like that. On number 11, this question really, it's almost so simple that you can kind of overthink it. It just wants you to solve the equation. Find out what the unknown is. Find out what y is equal to. So the first thing I do is subtract 5 from both sides and get that 4y equals 24. And then we can just divide both sides by 4 and get that y is equal to 6. And you're just going to put that 6 right here in the solution set. On number 12, we're going to evaluate this function, g of x. We're going to plug in c plus 2. Well, g of something is something squared plus 5 times something. Notice how I just put parentheses where that x was at? Well, now I'm going to plug that c plus 2 in those parentheses. So I need to square the c plus 2, and that's not simply c squared plus 4. C plus 2 squared is c plus 2 times c plus 2. So I need to FOIL that out. And when you FOIL that out and do that distribution, it simplifies into c squared plus 2c plus 2c, so plus 4c plus 4. And now I can say 5 times c is 5c and 5 times 2 is 10. And I just want to combine my like terms of 4c and 5c to get 9c and 4 and 10 to get 14. And this is our final answer right here. C squared plus 9c plus 14. Okay, on the next one, use slope-intercept form to write the equation of the line that passes through the point in the given slope. Well, I already have my b. It gave it to me. Whenever a coordinate's x value is 0, it's a y-intercept. So -6, b is equal to -6. Therefore, if I'm plugging those two pieces of given information into the slope-intercept form, my answer is y equals 2x, because 2 is m, 2x minus 6, because -6 is b. Now, in function notation, that would just be written as f of x equals 2x minus 6. So number 14, it is telling me that, well, really I'm going to have to write the equation of a circle, and then I'm going to have to graph it. But what it's telling me is that it's giving me the endpoints right here of a diameter. Now, I don't know what that diameter is. I don't know what the length of it is, but I do know that the endpoints are given to me right here. And just know this, a diameter is that length across the middle of the circle. That's a diameter. A radius is half the diameter. Well, why do we need to know what these terms are? Well, because we're going to find the equation of a circle, which asks me to say y minus h excuse me, not y minus, but x minus h squared plus y minus k squared, and it equals r squared. So I don't use the diameter in this equation for the circle. I don't plug the diameter in. I just use the information and divide it by 2 to get the radius, and then I'm going to have to square it. So to get the radius squared, I will have to use distance formula and do some things to it. To get the center h and k right here, I'm going to have to use the midpoint formula. And we use the midpoint formula right there because the center is the middle between those 2 points. So the diameter using this distance formula. The distance formula is the square root of x minus x squared plus y minus y squared. So I'm just going to say negative 22 minus negative 10 squared plus negative 12 minus 4 squared. So that comes out to be square root of negative 12 squared plus negative 16 squared. And when we square both of those things, we get 144 and 256. Add that together, that is 400. So the square root of 400 is 20, and 20 is the diameter. The radius would be half of that, which is 10. And when we plug this into the equation of a circle, it's going to be the radius squared, which is 100. So this whole x minus h squared, y minus k squared equals r squared, this is where the 100 will go right here. Now I just need to find the middle between those 2 points using that midpoint formula. The midpoint formula is x plus x divided by 2, y plus y divided by 2. And so that's negative 10 plus negative 22 divided by 2, and 4 plus negative 12 divided by 2. So negative 32 divided by 2, that would just give us negative 16. And 4 plus negative 12, that's negative 8 divided by 2, which is negative 4. So I have now my center. And we found that our radius was 10. We squared it to get 100, so I'm ready to put this into the equation of a circle. It will just be x plus 16 squared plus y plus 4 squared equals 10 squared, so 100. And just notice right here that when you plug it into the equation, it's the opposite sign of what you see in that center right there. You use a different sign. Now, I want you to be careful whenever you get to graph it, because if you'll notice, these tick marks are in units of 2. So we're going to go to our center of, and go by the coordinate, the center of, we found the coordinate to be negative 16, negative 4. So negative 16, negative 4 would be right here. And we're going to count out 10 units. However, it's in units of 2. So 1 unit is 2, 2 units is 4, 6, 8, 10. Three, four, 5. Oops, I went too much on that one. and 1, 2, 3, 4, 5. And so that would be our circle. The thing that you're going to have to watch out for on that one again is the units that are in 2. So when you move over one space, it's actually going over 2 units. On question number 15, it's asking us how to write the domain, or what is the domain of each of these functions. Well, on number 1, the thing that we had to worry about on all of these is it rational? Is there a fraction? If so, the fraction, the denominator can't be 0. And then is there a square root? Well, there's neither of those on this. It's not a fraction. There's no denominator, and there's not a square root. So x can be anything. Domain is asking you what can x be, and since there were no red flags here, x can be anything. Now, on this one, you're asking yourself, okay, wait, what can x be on part 2? What can x be? Well, there's a red flag, there's a denominator, and the denominator cannot be equal to 0. So we're not at all worried about the numerator. We're just worried about x squared minus 3x minus 28, and that denominator cannot be equal to 0. So that's a quadratic that we're going to solve. We're going to set it not equal to 0. So the factors of negative 28 that had to give me negative 3 are x minus 7 and x plus 4. So that means that x cannot equal 7 or negative 4. So that's the answer, but that's not the way we type it in. We want to type it in as an interval. So how do you get the interval? Well, think about it as being on a number line. Here's negative 4. Here is 7. The answer isn't from negative infinity to infinity, because that would mean x could be anything. But x cannot be negative 4, and x cannot be 7. So x can be from negative infinity to 4, or excuse me, negative 4, and then pick back up on the other side of negative 4 and go to 7, and then pick back up on the other side of 7 and go to infinity. So for the one at the bottom, it's the same red flag. We don't want the denominator to be 0. X can be anything, but because this is rational, it can't be something that would make the denominator 0. So we're not worried about the numerator at all. We're only worried about the denominator. And solve x plus 2 cannot equal 0 because that's the denominator. Subtract 2 from both sides. Negative 2 cannot equal x. So how do you write that in an interval? Again, think about the number line. Here is negative 2. X cannot be that, so it can be anything from negative infinity to negative 2. Pick back up on the other side of negative 2 and go to infinity. Question number 16 is asking us about domain and range. Well, for domain, we're looking at our x values. So where, from left to right, where do we start having graph at? Well, we start having graph right here at negative 3, and that has a closed circle, so that will get a bracket. And where do you stop having graph? Well, it started at negative 3. You work from left to right, so you keep going, and I realize we do have this skip right here, but it's not a skip in x values, because working from left to right, you have x values, we stop, but we pick back up at that same x value. This space is really a space in the y-axis, not in the x-axis. So from negative 3, keep going, keep going, keep going. We still have graph. Now we do have space again, but again, that's in the y-axis. This open circle is filled back in at the same x value of 1. So keep going, keep going, keep going, keep going. All of a sudden, we completely stop having graph right here. No more graph on this side. And that stop happens at positive 3, and it gets a parenthesis because it's an open circle. Now, our y values, you work from bottom to top for the range, and it's like, okay, down here I have no y values, I have no y values, I have no y values, but all of a sudden I have graph, and it's right here at negative 2. But then you work your way back up and you don't have any graph until you get to 1. And then you still work your way up and you don't have any graph until you get to 4. So what that is a list of y values, because those y values again happen at negative 2 and 1 and 4. So it's a set for the range, And the list of these numbers is in no particular order. It doesn't matter the order that you write them in. Now, I do realize I wrote them in numerical order, but when I list the numbers -2, 1, and 4, that's not an interval. That's a list. That's a set of answers, a set of solutions to what is the range for that function. Um, Anyway, on number 17, it's asking, is this relation a function? So all you had to do, since it gave you a graph, you want to do the vertical line test and draw vertical lines and see if you can draw a vertical line so that it intersects the graph at more than one spot, and you absolutely can. Right here I drew it intersected at 3 spots. So if you can draw a vertical line through it and intersect the graph at more than one spot, then no, it is not a function. It's Mama. It's Mama. On number 18, we're going to use the slope-intercept form to write the equation of the line. Now, that would just be using y equals mx plus b to figure out the equation of a line. Now, if I had the y-intercept, I could just plug it in on the end right here. I do have the slope of 2/5 that I am able to just plug it in. But since I don't know what b is, I'm going to use this slope-intercept form to solve for b. And once I have solved for b, I'm going to plug it back into the slope-intercept form. So the way we do this, if we use our point of -4, -3, we could say that -3 equals 2/5 times -4 plus b. And so now I'm able to solve for b. That would be, let's see, -8/5 plus b. And if I added 8/5 to both sides, that would give me -7/5 equals b. So I know that b is -7/5, and I know that the slope is sorry, I'm looking right at 2/5. So y equals m 2/5 x minus 7/5 is the equation of the line. And so this would be your answer for part 1. For part 2, where it wants you to write it in function notation, just instead of y equals, write f of x equals, and that's 2/5 x minus 7/5. For this number 19, write the equation of a circle in standard form. The generic equation of a circle is x minus h squared plus y minus k squared equals r squared. So the center that they gave to me is when it appears in the equation itself, it will have the sign will be different. And the reason is because the equation says x minus, and if h is -4, well, x minus a negative is positive, and so when you see it in the equation, it's changed its sign, right? Anyway, and so y plus 5 squared equals, so the radius is 2, and if I square 2, I just get 4. Now I get to graph this. Now, when I graph it, I'm going to go back and use this coordinate that they gave me of -4, -5. So going to -4, -5, that would be right here. And I'm just going to count out 2 units in any direction, okay? And so just place your point 2 units away, whether it be up or down or over, and that will give you your circle. Now, on number 20, the slope and the y-intercept of this line, y plus 3 equals 11. Well, I like to put my lines in y equals form, because if it's in y equals mx plus b form, I know that m's the slope. So I'm going to try to get y by itself. I end up subtracting 3 from both sides, and I get that y equals 8. Well, it doesn't really look like my form right here. And that's because a line that just says y equals a number is a horizontal line. It goes through the y-axis. So let me draw x-y axis. So here's my xy axis, and this line of y equals 8 is just crossing the y-axis at the y value of 8. And it's just a horizontal line. Horizontal lines have a slope of 0. And the y-intercept is where you cross the y-axis. So it crosses the y-axis at the y value of 8. And then the equation in slope-intercept form is just what we simplified it to up here. Y equals 8. On the next one, and graphing it, I guess I need to graph y equals 8. I already kind of graphed it. On the next one, so we're right in the center and we're right in the radius. So if we're looking at the equation of the circle, the center is the opposite signs of what we see. So the center is really -2 and -6. And if the radius squared is 25, then the radius is the square root of 25, which is just 5. Now for the very last one, it's asking us domain. We had a domain question earlier, and see, domain is always asking what can x be. And the last one, the red flag that we had was some fractions. And we had to make sure those denominators couldn't be 0. But on this one, we have some radicals. And here's the thing. We have some square roots. You cannot take the square root of a negative. It's imaginary. And yeah, you can solve it, but you can't have an imaginary domain. So what I want to do, I want to make sure that the inside of that square root is not negative. So anything that's not negative is greater than or equal to 0. If it's greater than 0 or equal to 0, if it's greater than or equal to 0, it's positive. So the inside has to be positive or 0, greater than or equal to 0. So to solve this, I subtract 25 from both sides and get -25, and x has to be greater than or equal to -25. So to write this as an interval, I like to graph it. Here's -25. If x is greater than or equal to it, it's going to the right, or equal to tells me I'm going to have a bracket. So from -25 to infinity is what x can be. On the second part, the square root of just and this printed out wrong. This was supposed to say the square root of 25 plus x, or excuse me, 25 minus x. So I would set that greater than or equal to 0. And I can subtract 25 from both sides. Now to get x by itself, you need to divide by a negative. And when you divide by a negative, you have to flip your symbol. So x is less than or equal to positive 25. In order to interpret the interval, I want to draw the graph. Here is 25. If x is less than or equal to it, it's going to the left. And we do get a bracket. So from negative infinity to 25 would be our solution there. Now, with the very last one, we have a square root, and we know we can't take the square root of a negative. So we normally set it greater than or equal to 0, right? Well, here's the thing. The square root's in the denominator, and denominators cannot be equal to 0. So instead of setting it greater than or equal to 0, I'm going to erase the or equal to symbol. And that's the only thing I want to do different. So x plus 25 has to be set greater than 0. I just subtract 25 from both sides. X is greater than 25, draw it on a number line, or x is greater than -25, draw it on a number line, and this time it gets a parenthesis. So from -25 to infinity.